Hello everybody, back again, KT speaking here, and this last talk in the webinars today is about more general topics, and I will start this session with some general thoughts about the expectations from us and the community about 3D printing in general, or other topics concerning rapid prototyping. And we've talked a lot about these things probably happened in the group and here at the university, and we think that it's very important what's happening inside this area of 3D printing. Not only 3D printing, but also rapid prototyping in general. And this little talk is about some consequences on this topic. I will start with some thoughts about what new tools coming into the world will change. And in my opinion, it's not only changing the world we live, the direct environment, the built environment, but also the society. And depending on the importance of a tool, it's changing a lot of stuff inside the society, and of course in our environment. And the second change is also every time it changes our personality and the human being itself. And this is very important, because if you don't be reflective in this thing, you will not be able to use new technology in the right ways. So, and our focus is on how students and pupils and young professionals will have to act confronting these technologies. And as an example, when you look at the wheel as a very important innovation in the last years, it's changing also the built environment. Of course, you have to look out, and you have to change also the personalities of many people, because you are acting as a different human being when you have the possibilities to go very fast from one place to another. It has changed the whole society. And we think that 3D printing as an example for rapid prototyping technology is changing the society and the way we work and nearly everything in our environment. Why is it so? We have in the last, let's say, 200 years, a very fast development in how we work and how we live. And as you know, these are the Industrial Revolution, and people are now talking about the fourth Industrial Revolution, because it's even more important what's happening now than but the first Industrial Revolution, when they start to build this machine, the factories, and the second Industrial Revolution, and so on. So what's going on? And I think we have to think about this when talking about 3D printing and rapid prototyping. Other technologies in this area are not only 3D printing, but also laser cutting, do it by yourself, and these little easy to program computers like Arduino, Raspberry Pi, and so on, where even a child has the possibilities to introduce new things to the world. Very individual things, and it's very important for us to have a look on this, because it's changing our way to think and to work. And next thing is, when we have a look at these main two columns in industrial and handcrafted society, like factories on the one hand and handcraft products on the other hand, we have until the last years two main columns. On one hand, we have these industrial mass production of products like cars, tables, chairs, and so on. And on the other hand, we have these individual made products made by craftsmen, and they are very individual, but normally they are also very expensive, and it's not so easy to make them. You need a lot of experience to do this. You you choose your profession, you have to learn 3 or more years to make this product. And the advantage of the industrial made products is they are very cheap. Normally, if you can make it very fast. You have very high. You can produce very fast, very big amounts of products, and so we think that in these days we will have the beginning, or if we are in the middle of the changing, that these 2 columns will merge to 1 column, because now with these technologies we have the opportunity to make our own factory. Yeah, the message we bring to our students is: you are the factory now. Yeah, you don't need any big factories somewhere in the city or outside the city, but your factory is at home. And with all these possibilities made by computers, you can design your own products. You will get now the opportunity to make your own product also. Huh? Normally, till now, you have to you can design a product, but you have to find somebody who will produce it, and this is changing now. Yeah, as you can see in all these do-it-yourself communities and the Fab Labs and so on. And when we face this, we have to take care about that. Now we are in this process, and when you are in a process, it's not so easy to realize the changes taking place now. So what is very important, in our opinion, to all these people who are now in this time by using these technologies, is that they have to reflect what's going on and what does it mean for themselves and for the society and all. When you have these students here at our laboratory, it's very interesting to see them, because sometimes the students know much more than we do, because they are growing up with these technologies. They are not so reserved about these technologies. They have sometimes more experience, you know? So it's changing not only the way we are acting inside the industry or in the society in general, but it affects also the way we have to learn and we have to teach. And because the things are very fast changing, yeah, on the one hand, and on the other hand is that the roles of teachers and students are sometimes changing, because sometimes they know much more about this topic than we do, yeah. And these consequences leads to 2 pillars, which is very important. I think we have to teach all the students and ourselves as a teacher that we have to make a lifelong learning in general. Yeah, we have to learn every day new things about what is going on and what will be changed through this changement. And the second one is we have to learning on demand and lifelong learning. Yeah? When we have to face a new problem and we have new tools, and it's a rapid changing world with new tools, we have to reflect on these tools and know exactly what this tool is good for, but also what it's not good for. And the students, we have to act in this university. Of course, they are very interested in these new technologies, but also they have, as we are, we have also a very idealized opinion about new technologies. They can solve all our problems, and of course this is not the case. Yeah, they can change something when we are reflecting what is the good side and what are the good sides of these tools, but also recognizing what are the bad sides and what are the sides of a tool which are not so very effective and so on. So when we have a look here at our laboratory, we have of course some examples which we will show in advance in the end of the seminar here now. And on the other hand, I would show you not only talk about the good things about the tools, but also about the challenges and the risk which are now growing up. And one of the limitations, of course, in 3D printing, especially, is the limitation of speed. Normally it took several hours to make a product itself. And this is a problem which I think can be solved, and is solving now, because there are new machines on the market, they are faster and more precisely. And this is changing, like you can see in the history of computer science itself, where the first computers were very slowly, very big, and very lazy also, and it's changed very quickly. Yeah, and I think we can hope that these problems, the limitation of speed, is changing in the next years. And the other problem seems to be that the material is very. There are not so many materials on the market which are printable with 3D printers. Normally we have these plastic materials, but also wood materials are possible, and steel, but it's very limited, because when you want to make a product like let's say a shoe, as we have seen in the last example here, the shoes are consisting of different kind of materials, yeah, and it's not so easy to make by it's not so easy for a 3D printer to get this goal a normal shoe has, because it's very complicated, the different kind of densities and stuff. Yeah. So the limitation of speed is one thing. The limitation of available materials also maybe bigger, because you can't print everything. Yeah. Now, but maybe it's changing. We hope also that it's changing in the next future. The last thing is that the post-processing of the rapid prototyping, especially 3D printing, you have a lot of post-processing, which is normally made by hand. So you have an industrial product, and you have to prepare it and post-processing it by your hands. And this makes it even slower than that we have with the production of the product itself. So this post-processing topic will also lead to a lot of changes maybe in the future, that the post-processing is made by the machine, and yeah. But on the other hand, there are also risks about this technology, and this is our risk concerning new tools in general, because we have, let's talk about two main risks, I think. The one thing is when you have only one tool, you know, then every problem you face in your environment, you think you can solve this problem by your new tool. Yeah? So if the only tool you have is a hammer, then everything is a nail. You can put your hammer on it, because this is not the solution. Yeah? A new tool coming into the world is, you have to reflect on it and know very exactly what is it good for, what is it not good for. And I hope the learning path we've made in this project will also show the students and the young professionals about these limitations of the product until now, so that they can use the 3D printing as a good tool for many things, but not for all things. They have to integrate this new tool inside their toolbox for their professions. And the second risk, in my opinion, is that when you have a new tool and you are not reflecting on what this new tool can do for you, you are using it in the wrong way. And we know when we are here at the Faculty of Architecture that when the CAD systems were introduced many years ago, the houses coming out of the CAD tools looks like they are coming out of a CAD tool, not made by hand. Because when you sit the first time in front of a CAD system, in this case in a new tool, you are not reflecting and just use it. And the computer has some advantages, like copy and paste and make the same thing every time again. So the first years in this experience was that the house coming out here at the front of faculty are looking like computer houses. So you have to think about it. And for this first section, I want to close it by showing you an example about a topic we've introduced here. It's an experiment with the students where you can see here this little handout here, and this is in the back you can see here a painting from a German artist, Neo Rauch, and there was a big exhibition some years ago, and we were pleased to make some handouts for blind and visual impaired person to go inside the museum and see the pictures. So we have made with the students an experiment and said, okay, now we have all these tools, and you have also your hands. So make some little handout for the blind people that they can see and touch by touching these exponents here to see the picture. So, and they have also some conventional tools here in the house, but also these new tools like 3D printing in this part here, and subtractive machines like this here, and laser cutting, and also parts of this are made by hand. No? And they have to reflect very seriously about the advantage of these tools. Yeah? And in our opinion, this was a good example about integrating a new tool to an existing box of tools for the students, and we hope to extend this experience with next students coming up in the next year. And as a conclusion, I would say we have to very reflective about new tools, and these new tools will change our environment and our personal way of living. And if you don't take care about what is going on here, we have an influence about these changes. Yeah. So I close this part and leave the stage for the next participant. Thank you very much.
Okay, good morning everyone. In this part of the webinar, we are going to discuss the sectors in which the usage of 3D printing will grow the most. Before getting into each sector, we'll first analyze some future trends that are expected to impact the role that 3D printing has in today's industries. So far, rapid prototyping has had an important role in the industry. What the trends are showing us is that it will still be important, as it can be clearly understood, but at the same time it will not have a key role. That is to say, it will not be a game changer that will expand the technology into high volume use cases. Hence why The current industry should instead be oriented towards printing more multifunctional and finished products or components in volumes that can outnumber the volumes produced by prototyping. For example, some markets have been adopting 3D printing to finalize dental braces. Therefore, 3D printing technology can also supply products and components that are usually manufactured traditionally. As you can see here, these are the industries which are expected to be more affected by 3D printing. In bold are the industries in which the usage of 3D printing is expected to grow the most. The automotive and industrial manufacturing, aerospace, pharma and healthcare, and consumer goods industries. Now, let's analyze each of them. You will see that in many cases, 3D printing is already being used, but on one side there are some regulatory barriers which do not allow to exploit its full potential. On the other side, what emerges is that this technology still needs to be used and tested in many specific fields, for which analysts are showing positive trends in the near future. So let's get down to them. As for what concerns the aerospace industry, what emerges is that lightweight structures are currently the most wanted by producers. At the same time, there is a demand when it comes to designs for adding strength to components. That is because one of the most important things that producers are trying to reach is a lightweight structure, but with as much strength as possible. That's why the research and development of new materials and differentiation features is also currently ongoing. Plus, one last concern from the side of the producers is that the lighter the structure is, the lower amount of fuel the final product will consume. 3D printing can therefore be the answer to many requests coming from them. It allows to produce lightweight components in a cost-effective way and without the need for production tooling. This will of course lead to a lower fuel consumption as well as lower costs for what concerns the materials used and definitely less CO2 emissions in the air. Secondly, all we know, engine and turbines are extremely important in the aerospace industry, and it is even more important when it comes to think of innovative technology, since this is exactly where it can produce most of the benefits. 3D printing can offer functional components with complex geometries and defined aerodynamic properties that can be manufactured quickly and cost effectively. Through the use of a laser sintering technology, for example, 3D printing can produce lightweight design which still have strength and weight reduction that goes around 40–60%. As a result, the airplanes will consume less fuel and emit less carbon dioxide. For what concerns the automotive and industrial manufacturing industry, the producer's priority in this case is always to shorten up the development cycle on one hand, and on the other hand to reduce the general costs of production. AM technology has been an important tool in this field, although it is currently only used for prototyping and direct manufacturing of small, complex and non-safety relevant components with small series. Innovation, new technology, low cost of development and expiration of key patents are all key factors that drive 3D printing in the automotive market. In fact, it can offer multiple ways to reach the goal in less time and with less money. For example, using 3D printing technology, a producer is allowed to consolidate many parts and components into a single one. This will definitely shorten up the production cycle and will also allow to perform a form and fit testing on the product. Secondly, 3D printing will also allow to create a production tooling as well as produce spare parts and components. However, one remark has to be made. Currently, the main obstacle for the usage of 3D printing in this sector are mainly derived from regulatory hurdles which differ from country to country. So it has multiple consequences. 3D printing is also widely used in the pharma and healthcare industry in the creation, for example, of processes and implants, medical instruments, modules, but also dental implants. However, 3D printing can offer even more than that. Surgeries, for example, can be planned using models based on CT scan or MRI. At the same time, one key concept that is really part of 3D printing in general is customization. In this sector, for example, 3D printing will allow to customize orthopedic implants and prosthetics in order to adapt them to specific needs. And at the same time, medical training can be performed on 3D printing cadavers, while human tissues can also be created for regenerative therapies. 3D printing in the electronics industry can offer much more than what it seems. Currently, it is adopted in order to develop prototypes, new products, and concept design. But the future applications of 3D printing in this sector are many more. The next big opportunity is represented by smartphones, which are estimated to be 35% of total consumer electronics sales. Smartphone manufacturers are slowly moving from being prototyping applications for 3D printing, with more growth projected in the near future after advancements in materials and equipment. In the case of large consumer electronics, meaning for example TVs, 3D printing would allow to reduce design validation times from 1 week to 1 day, with fit and finish improving significantly and better results. Positive outcomes can be registered for large computer accessories, with new manufacturing tools being developed. Finally, in the case of small consumer audio headphones, 3D printing will allow to enable customization and improve the process and the workflow. As already said, one key concept that has emerged multiple times already in customization is customization. This is also very important when it comes to the consumer goods industry. Currently, 3D printing is used in rapid prototyping, customized jewelry and watches, but in general, customization of products is rather limited currently. 3D printing in this sector can be used for several other purposes, mainly related to customization. For example, it would allow customers to agree with the producers on how they want their products to be, and therefore to co-design them together. This can also lead to a growing mass customization of the products. We hope that this webinar was interesting and at the same time useful to you, and that you got an overview on what 3D printing is already doing, but moreover on what it can do in the very near future. Thank you so much for watching this. Further details can be found on the official project website. We'll leave the floor to Keith right now.
Please. Yeah. Okay.
Hi, I'm Philip. I'm the lab assistant from BLM, and I want to give you an insight how students at our faculty, architecture faculty, work and use 3D printing. First, I think I just can describe the position of an architecture student. All the stuff we made are for models, for the finals, for example, and 90% are some filigree parts that are hard to make by hand. For example, winding stairs, small stuff like this, and the furniture to make the models look better. The students see the 3D printing technology more as a time saver, because you can create the stuff on the PC with a CAD program and then put it on the printer, and in the meantime you can prepare your presentation or do other stuff on your final model. And for example, when you every student here knows how it is to put a little winding stair together piece by piece, and maybe it took half an hour to make it, but the 3D printer can produce 10 of them in like 2 hours, and it's much more efficient and much more faster, and it looks better, definitely. I got here some example models we use. This is from an old filament printer. It's you can see all the layers, and it's pretty rough, and it is also, it took a lot of time, and the old machines are more setting based. I don't know how to describe it, because it's more geeky stuff to make, to find out the right setting, how the extruder will heat, how the filament is put on the plate properly. And we got new machines like the stereolithography printer. You can, is it gone? Okay. And then, okay, go on. I just like the stereolithography printer, which you could see, but not now on the camera. It's a much better resolution of the model. It looks like it was one piece, and you barely can see any layers. Another project we made is was a joint venture with the biological faculty, and I got a master student here which wanted to create a reactor made of clear resin, in which you can grow plants which create ethanol. And that was, for example, then when we produce a reactor, we noticed that 3D printing is not the only way to go, because it was too complex to create, and then we decided to combine more manufacture ways. For example, we laser stuff, put it together with a 3D printed body, and we put together the reactor. Was some scientific application we made here. Another problem is that the students mostly think, when they never use the 3D printer as a magical machine, the way you just press on print and the model comes out. It's just like Volker said. It takes time to make a model, and the students got the problem that they think they can print everything, and mostly the models, it's a question of the geometrical design of the models, and you can't print everything, because if it's too long and too thin, then the the printer cannot create it, or it is too much support structure needed, and this is how the print will get more expensive. And I can say something about the software. We use preform from Formlabs, and it's a pretty new software to which is combined with their Formnet printer, and it's pretty intuitive, because you can just drag and drop your 3D model in it, and the software will generate just can't figure out the word, the weak spots of the geometry, yeah, and figure out the weak spots and show them slightly red, and you can rotate after that the model. It's pretty easy, and then you can just put via mouse click additional support structure on the model, and you can. It's pretty accessible for beginners, and yeah. Okay, I'm done. It's okay. Thank you.
So, thank you very much, Philip. This is the end of our third webinar today, and we are open to your questions from the audience. Please feel free to describe your questions in the chat channel, and we hope we can answer your questions. So in this context, for me, it's important to announce that it's an ongoing topic, which is changing very rapidly, and we have to have a strong look on what's going on here, and also the platform and all these training materials has to be developed during the next years, because I think, and I hope so, that the machines will change, and there are a lot of good opportunities inside these technologies to make new products, to make better products, to make more individual products, and to bring these columns together from a technical fabrication inside factories on one side, and on the other side is handcrafted machine. And as I mentioned before, this, in our opinion, this is the main effect now by these new technologies, rapid prototyping technologies. So there's one question coming up. Yeah, when this will happen? This is an interesting question, because it happens now. Yeah, this is one thing. I think it's important to reflect on what's going on. And in the last century, last 2 centuries, the development of new tools are so quickly and so intensely that, but when you are inside this development, you cannot feel the development. Yeah? You are inside, no? And after some years you are inside, you have noticed that the world has changed. And I think with these technologies, we have to do now these things, these effects on our society and our art of work and kind of work, what and how we are doing it. it's even more faster and more intensity like before. And when you have a short look at the computer technology of the last 40 years, 30, 40 years, it's changed everything. And although the smartphone, it's just 10 years ago, and now the way we are going through the world has changed immediately. Yeah? And the other thing, which are in the same category, it's like rapid prototyping, in my opinion, is the virtual reality stuff and the augmented reality stuff. They are the next big things coming up now, because they are not new topics, but they have now changed a little bit the role of now they are for the consumers. Yeah? In former times, when the first virtual reality technology came up, it was too early. The machine, the computer wasn't so good, so fast, and now it's coming up again. It's my impression that virtual reality and augmented reality is a very successful model, and very next tools coming up to the market, because now the machines and the bandwidth of the networks are much more better, and I think this is happening now, yeah, and yeah, we have to take care about it, what's going on, and because if we don't do this, we will be not more the creators, but only visitors of this scene. So, yeah. Do you have another question? Yeah, the question about the main skills, in our opinion, young professionals should become in this education. I think I've mentioned it before, because the main skills are it's something like an openness mind for this technology. Yeah? You don't have to use it, but you have to know what's going on. That's the main skill. And the main skill next main skill, in my opinion, is that you have to learn very quickly. Yeah. And for young professionals, it's obviously that they are not in the same comfortable zone like years before, when you finish school, learn one profession, and then you stay in this profession for the rest of your life. This is not the case anymore. Yeah. When you now finished your school and your studies, you are in a rapidly changing world, and you have to reflect what you're doing, and you have to change your life and your profession much more faster and quicker than you have to do it before. Yeah, and this is a good message, but also a bad message, because you have to be prepared for this. And in my opinion, the most important skills for everybody of us, not only for the young people or for the older people, is to be ready to change ourselves, yeah, our behaviors and our opinion. And we have and when we recognize this, it's very interesting what's going on, and we have a good connections to the world by all these communication devices, and of course also in the European community to learn from each other and reflect on our behavior and do very good stuff in the near future. So that's it. So it's up to me to close this last session for today. I think we have seen a lot of interesting stuff here, and the webinar will continue on next Monday at on which time? At 4 o'clock. And I hope to see you all again, and maybe you can think about in the next days about what is your opinion to this topic, and ask it here in the channel and the community. Thank you very much, and see you again. Bye.